Hello everyone. Today let's see at the logistic regression. We'll see how it works, and we'll also plot a heat map for the predicted values and the true values. So here we have one data frame which has two columns, monthly salary and owns a car. So this owns a car column, which is a dependent one, we has values of 0 and 1. So 0 represents an employee or a person does not own a car, and 1 represents it does own a car. So let's segregate the data between dependent and independent variables. So for independent ones, so monthly salary is the independent, so we can have monthly salary like this, and then the dependent one, which is owns, what was the column name, owns underscore car. Okay, okay. Now let's do some data preparation. For that we'll need trend split from sklearn's model selection. I can have trend rest split, which will take x, y, which will also take test size as 20% and random state 40, which can be any value, just to make sure of reproducibility. And in return it will give us x train, x test, y train and y test. Now let's train our model. What kind of model? Logistic regression. sklearn.linear model import logistic regression. Yes. Logi model, that will be variable, and for training it will pass x train and y train. Fine. Our model is trained. Now let's predict the values. Model dot predict what? For that we'll need to pass test. It is not model, it is logi model. Okay, now it has predicted the values as well. Okay, so these are the predicted values. Now let's use something called as heat map. Before using heat map, let's use one metric called as confusion matrix. sklearn dot matrix import confusion matrix. Okay, now this confusion matrix will take, just as any other metric like MSC or anything, it will take two values, two arguments, like y test and y predicted. Now in return it will provide a 2D array 2013. What it actually is, before discussing that, let's plot it so it will be easier to understand what it actually is. For plotting, let's use Seaborn, import Seaborn as SNS. So here we will use SNS dot heat map, which will take an argument of this confusion matrix. it has plotted a map, a heat map. Now in these rectangles I also want these values to be printed. For that we have one argument annotation which is true. Oh, we are not in Java. Keywords annotation, or is it annote? Okay, it is annote. Now as you can see, one more thing I want to do before moving forward. Let me create a list which will take two values, does not own a car and own a car, and that I'll pass, that list I'll pass here values. What was that argument? SNS dot heat map. Control tab, xtick labels, that is the one. Xtick labels is equal to values. Fine. Same we have to do with the ytick labels values. Let's do one more thing. Let's decorate it more. Import matplotlib.pyplot as plt. Let's name x and y axis as well. plt.xlabel. These are the predicted values. It's not working. And plt.y label is true values. Okay, now if you see at this heat map what it is showing, so it is showing us a true negative, true positive, false negative, false positive values. What does that mean is, you see here the one value is there. We have predicted that the user or the person does not own a car, but actually it does, so it's a false negative. But if you see here the 2, here we have predicted he or she does not own a car, and the true value is it actually is he or she does not own a car, so it is true negative. Similarly here in 3 we have predicted it owns a car, and true value is yes, it really owns a car, so it is true positive. So if we see at this diagonal here, so we can see that it is the true values, true negative, true positive. And here the 0th one, where we haven't predicted that it is own a car and it does not own a car, so that's fine. But if you see in the heat map, the diagonal, it has the true values and it matches with the predicted ones and the true values. So the accuracy that we will get is that 3 plus 2, which is 5, divided by the total values, which is 3 plus 2 plus 1, 6. So 5 plus 5 by 6, and whatever is the percentage, that is our accuracy.